Hello everyone, this is the video lecture for Pre-Calculus Chapter 4.6 and 4.7 put together. Particularly talking about models. So models means word problems, basically. Let's just jump into it. There's nothing really new here. So 46007. They're talking that there's two different kinds of rates, population growth rate. So we got a rate of 3%, and a rate of 2%. And they're saying that we have a population in 2011, which is 130 million. I didn't spell million very well. The population in 2031 is what they're looking for. They don't know what that is. So given these different rates, what would it be? And then so we got t is equal to 20 here, if you can tell the differences in the time. So part A, they have the 3% rate. And so I'm just going to tell you the formula here is pretty easy. It's going to be the A equals A naught e to the kt. And so we got the 130. E to the k is my rate, so 0.03. T is time, so 20. And let's find that in a calculator. You get 236.875. Again, that's million. Part B is now doing the 2%. Same thing. 130 e to the 0.02 times 20. Put in the calculator 193.937. Again, million. Okay, cool. You can see it's not very hard. It's just, taking the word problem, dissecting what they're even asking for, and just taking the information you need. So 4.6.12 is actually a very particular problem. It has this exponential growth going on here. It starts at a 100. There's another point here at 2,225 for me. I call this one the frog problem. So there are distinct questions in this class that even I remember, every single semester they come up. It should give you a hint as to the fact that, hey, this is an important question. It's something that we ought to take a second to, know, to remember, to see the style, okay? So, frog problem, it's got its own name. This is an important one, okay? Cool. So first off, part A, they say, what's the initial population of frogs? Well, it's actually this 100 right there. That's at t equals 0, essentially. So just put the 100 in, whatever number you got. Super easy there. And then they're saying, okay, well, now we want a formula, n of t, the number of frogs over the amount of time. So my basic formula here, I'm going to go ahead and tell it to you, is the y equals 100 e to the rt. It's kind of like a PERT formula, P-E-R-T. And just like we did above the last problem as well, I'm using the 100 as our initial because it's our initial. We need to find a rate, and so I'm going to go and plug this guy in. And remember, that's an x and a y. I guess you can say that's a t and a y. And so plugging it in, we got the 225 is equal to 100 e to my rate. I don't know, but the time is a 2. So I'm going to divide by the 100. And I got a 2r there. In order to get rid of my e, I'm going to ln both sides. Even if I didn't have an e and I had some other number, I would still be lnning both sides. But regardless, here it's easy because it cancels. So what I'm going to do now is divide by that 2 to the other side. So my rate is equal to ln 225 over the 100. And then all divided by the 2, which you go to the calculator, and I got 0.405465. Okay. Now, I don't want to box that in because they're not actually asking for that. That's just my rate. Thankfully, we got the rate. But they're really wanting the whole formula. So, my part B answer actually should be y equals, or I guess they have that n of t equals. And so what do you put in the box is going to be that 100 e to this rate, 0.405465, and then a t. They want it in terms of t. So there you go. Now we have a formula for the amount of frogs over the amount of time. The problem continues. Part C, it says, what's the population after 13 years? And so, okay, that's t equals 13. I could just, well, plug it in. And so I got the 405,465 times 13. Plug it all into the calculator, and what you get is a 19,470.7805. And this is, guys, this is frogs. That's a lot of frogs. That's a lot of frogs. And then D says, how long until we get to the 22,000 mark for frogs? I don't know. Maybe that's just some particular thing there. Well, that means that my answer is 22,000 equals that 100 initial. I mean, guys, we started with 100 frogs to start with. 13 years later, we got like 20,000 frogs. That's a lot of frogs. But that's good. I mean, maybe, endangered species, and we're trying to bring them back up in the Amazon or something. I don't know. I'm just thinking out loud. And so I'm saying my formula here is equal to the 22,000. What do we do? It's funny what you do, and I'm going to show you this, I guess, slowly. I'm pretty sure we did this at some point, but we can divide by the 100. There's a quicker way than all this. I'll show you here in just a second. Lots of copying. You ln both sides. I'm sure I could just cancel some zeros there here in a second. Oops. Cancel. And then I'm going to divide by this decimal here. Divide, ln, divide. And if I haven't already showed you in some other problem, it's been like a whirlwind here. This is the trick. So let me use a different color right quick because this is really awesome. If you see this format right here, see the numbers, first number, second number, third number. Yeah. See this format? First number, second number, third number. Same thing, right? Same thing. So like burn this in the brain. Keep this in mind. You see how that progression works? So as long as you're doing ln of something over something divided by something else, so you got like, your one number, your other number, and your other number. It's that same progression that you would have this way. Okay? And that's just a quick way. That means you can basically skip to this without having to do all the divide, ln, divide. Just a little trick. So 13.301, again, this is years. There we go. So it takes 13 years to get up to the 22,000 frog mark. 46020. This one talks about radium-220. And thankfully they give me the half-life because I don't know what the heck that it would be. The half-life is 30 seconds. That's very fast. So it says, how long until 89% is decayed? Now, this is an interesting set of English. If you remember doing some of this half-life problems back in your college algebra class here at Citrus Texas College, they often didn't use these words here, how long until this much is decayed. They would say how long until we have this much left over. Okay? And there would be a particular formula that I would use in that style. Well, WebAssign's kind of doing the opposite here, okay? So if 89% has been decayed, that means 11% is remaining. Okay, so I'm going to keep that in mind as I keep going through this. I'm going to show you my formulas, okay? And I just use these in my algebra class. So rate, or your R, I guess you can also use K. Doesn't really matter. Either way is fine. I think K is normally what I use. Your rate is ln of 0.5 divided by the half-life that they give you. Now, why is it 0.5? Well, that's half-life. You see the point now, right? So it's half-life divided by half-life, kind of. and you get your answer. So ln 0.5 divided by the 30, just plug it straight in, and I got a negative 0.0231 04906. I just ran out of room, but this is good enough. That's not your answer by any means. They're wanting how long, they're wanting a time, so we're going to do the time here in a second, but we're going to need that in order to get that time. So time equals, what's my formula for that? Ln of the percentage remaining. So I want to do percent remaining. I know I didn't spell it very well. Divided by the rate that we just found. I'm going to just write rate. That's good enough. And so the percentage remaining is 11%, and my rate is this negative 0.0231 And so I put all this into the calculator once, and again, I'm wanting to go as long as possible with these decimals, so I'm even cheating just a tiny bit by not writing it well enough. Don't cheat on it. Don't don't skip any numbers. I know 6 is safe, and that's fine, but we want to go as far as possible with our decimals. I just ran out of room, so just write them all out, okay? And then we get this amount. I mean, it's straight up just calculator. So Formula 1, Formula 2, these are awesome formulas, and I totally recommend writing those down on like a note card or something, because they will come up occasionally. 46026. So this is actually Newton's law of cooling. They tell you that. What they don't tell you, sadly, is the formula. So I'm gonna have to tell you that. But they say that we're gonna start at 98.6 degrees Fahrenheit. It's kind of interesting, particular. I can't remember what the problem's exactly about, but obviously that's like the body temperature of a human. And then we got K is this much. They just tell me. And they say there's an ambient temperature of 60 degrees Fahrenheit. Okay. So what's going on? Well, part A says find the temperature in terms of T. Again, there's T of T. Kind of weird. Temperature is what they're actually looking for, okay? So blah, blah, blah degrees Fahrenheit. But this is in terms of time. So over time, the temperature is going to go down, Newton's law of cooling. And so I'm going to give you this formula. This is something that you should write down somewhere, okay? This is very important. So here we go. My temperature is equal to my start temperature minus the ambient times E to the K. It's a negative K, actually. Negative KT plus ambient. There you go. There's your formula right there. That's your formula. I am literally going to just plug it all in as you see. So 98.6 minus the 60, E to the negative 0.1947T, and then plus the ambient again at 60. There it is. You do not need to simplify this for WebAssign. You don't ever need to simplify stuff, okay? As far as I remember. So keep it like that. That's very good. Part B. They're saying now if the temperature was 71 degrees Fahrenheit, what's my time? Okay. So I'm starting at the 98.6. I find this at 71. How long did it take to find that? So I'm going to take this as my my formula, and this my answer is 71 is equal to all this stuff. I feel kind of silly like rewriting it so many times, but that's the math for you. Solve for T. The first thing I'm going to do is subtract the 60, so I got an 11. And actually, this guy right here, I can also combine like terms to make the 38.6. Divide. To get rid of the E, you're going to ln. Probably at this point right here, don't you notice that I could have done that progression thing again? I just get so wrapped up in the problem that sometimes I forget my own tricks and techniques. But yeah, you could have just done right here. You could have just, ln 11 over to the 38.6, all divided by the negative right here. So you'll be seeing this guy here in just a second anyways. E and ln cancel, divide this to the other side, and sure enough, we're just copying that guy now. Okay. Calculator. Put it all in at once, and I got 6.4476. This is in hours. Whew. I've got 2 more problems for you, and these are unique problems, okay? They're unique. They're different. And again, they have special kind of like names, so it's important because I remember them. Therefore, I think you should definitely write these down or do a little side note or something on these guys, okay? So this is talking about pH levels in wine, okay? So it's the wine pH wine, I guess, problem. And so they give us that red wine has a pH level of 3.3. White wine has a pH level of 2.5. And so it says, find the hydrogen ions. Blank M. Like, I don't think that's moles or something. I don't know. I have no clue. Go. Figure it out. Well, I mean, again, they don't tell you a formula. This is just way off the wall. So I don't know how you're supposed to do this without a formula. So again, well, what is that formula? Well, let's go over it. Your formula is, I don't know, this M or whatever we're going to get the answer is 1 over 10 to the power of the pH that you're given. So that's a pH power. Kind of strange. So let's do this for the red in particular right now. So I'm going to say 1 over 10 to the 3.3 power. So this guy's all on the bottom there, okay? And I put that in a formula, and I'm sorry, in my calculator, I get 5.01187 E negative 4. Now, watch out for this, okay? They're not going to want this answer in WebAssign. The E negative 4 is meaning that we're going to be moving that decimal place 1, 2, 3, 4 times over, filling in the zeros along the way. So therefore, you actually get 0, 0, 0, 5, 0, 1, 1, 8, 7. That is what their first answer is. For the white, very similar. We got 10 to the power of 2.5. And so when I do this in the calculator, it comes out with a nicer decimal. 0.0316227 just straight up. There you go. So watch out for the scientific notation a little bit as well. Okay, last one, 47012. So this is the earthquake problem. Talking about earthquakes. And so we got earthquake A, and we got earthquake B, and they give us these Richter scales. So then we got 8.3 on the Richter scale, and this guy is a 4.5 on the Richter scale. If you know anything about earthquakes, 4.5, I don't know if that's big or not, but I mean, it's not anything compared to the 8.7 or the 8.3. This thing is super, super, super huge. Super, super huge compared to this guy, okay? Just in comparison. And that's actually what they're going to be asking for is how many more times intense is A to B. Okay. Again, they kind of leaving you without a formula. So what you actually have to do here, this is a kind of pseudo formula. The Richter scale stuff is 10 to the, I don't know what I would call it, Richter scale R. It's good enough, I guess. And so then we got 10 to the 8.3 divided by 10 to the 4.5. And see, because they're saying how much more times than 10, so then it's a ratio of some kind. I put all this into the calculator at once, and I got a 6309.57, 3445 times more intense. Look at that, 6,300 times more. That's like multiplied. That's how much bigger it is. Okay, we're done. We're done with all of Chapter 4. So if you have any questions at all, you let me know. Thank you very much. Have a great day.